Hi everyone, we'll continue with the numericals on refrigeration. We'll take down one problem. All of you please note down the problem. An air refrigeration system working on an open cycle is required to produce 25 tons of refrigeration with a cooler pressure of 12 bar and refrigeration pressure of 1 bar. This is 12 bar and this is 1 bar. So refrigeration capacity is 25 tons. The temperature of air leaving the cooler is 25 degrees Celsius and air leaves the room at 0 degrees Celsius. So understand all the things. Temperature of air leaving the cooler is which temperature? Cooler, if it is leaving, it is T3. Leaving the air means it is air from the room, means the room temperature is initial temperature is 0 degree. Assuming the cycle with isentropic compression and polytropic expansion with n is equal to 1.35, determine mass of air circulated per minute, compressor and expander piston displacement per minute, COP, power required per ton of refrigeration. So here these things are very important. So one is what? Here as compression process, if you are using compression means what? 1 to 2 you are going to compress. So here it is happening with isentropic compression. So just I'll show you this here. So here whatever we are using here, it is PV raised to gamma is equal to constant. Why? Because he has said wherever there is a isentropic compression, it is assume the cycle with isentropic compression. Isentropic compression means it is adiabatic. So here you have to use gamma is equal to 1.4 and polytropic expansion. Here the things are expanding. Here PV raised to n is equal to constant and n is 1.35. So this is little bit more informative and attentive is required. Presence of mind is required. Don't take every time while calculating T3 or T4 you should take 1.35. While calculating T2 or T1 you should take 1.4, because this is happening with the adiabatic and this is happening with polytropic. Here index is 1.4, here index is 1.35. Within the process only he has changed the things. Let's write the given data. TRE is refrigeration effect is 25 TOR, that is 210. If you multiply you will get 5250 kilojoules per minute. So pressure, initial pressure, refrigeration pressure is 1 bar, P2 is 12 bar, because these are only the two temperature ranges we can see here. And T1 initial temperature is 0 degree. So 0 degree means 0 plus 273 Kelvin, n is 1.35. T3 has given the air leaving the cooler. So cooler is from 2 to 3. It is cooler. Leaving the cooler is T3. At T3 it is going to leave the cooler. So it is 25 plus 273, 298 Kelvin. COP I have to find out. Mass of air, power, V1 and V4. So this PV in this diagram, V1 and V4 I should find out. Next. So isentropic compression process. See here I already said it. Isentropic compression process 1 to 2. So to find out T2, because T1 is given, P2, P1 is given, you have to use 1.4. Here you will get T2 as 555.26. But while calculating 3 to 4, again I am repeating, here it is gamma, here it is n, but n is equal to 1.35, here gamma is 1.4, always it is fixed. So T3 is given, I should find out T4. T3 is already given, T4 we have to find out. Here also T3 by T4, P3 by P4, but these are constant pressure process. So P3 is equal to P2 and P4 is equal to P1. So T4 is equal to this one. So now refrigeration effect per kg. Initially we will solve, keep everything ready, because further things we need this. So refrigeration is happening at what? It is happening at evaporator. So Cp into T1 minus T4. 1.005 into 273 minus 156.47, 117.11 kilojoules per kg. So now one by one solution will solve. Mass of air required, we know that ton of refrigeration effect divided by refrigeration effect per kg. So this is 5250, this is 117.11 is equal to 44.83. This is by mistake he has written like here. So here 44.83 is mass of flow rate of air within the refrigeration system. Next, power supplied we are seeing here again compressor work and turbine work. Instead of turbine I can say it is as a expansion or expander work. So WC and WE. So compressor work, how we have to calculate it is going with the adiabatic process. So gamma by gamma minus 1 into P2 V2 minus P1 V1. So instead of P2 V2 what I will write MAR T2 minus T1. MA is calculated, R is known, gamma is known, T2 T1 values are known. Only compressor work we have to calculate 117.06 kilowatt you will get. Expander work, only instead of gamma we need to substitute n divided by n minus 1, and here P3 V3 and P4 V4, but P3 is equal to P2 and P1 is equal to P4 is equal to V4. So PV is equal to MRT, again you supplied MR T3 minus T4. So here T3 T4 are known, MA is known, R is known, and N value is also known. You will get 117.06. You just check the values are correct or not. So this WC I suppose it is 211.84 he has written here. So this is wrong I think so. So just calculate here and this substitute this value. It comes around 211.84, right. So substitute here, you will get the value. So what value you will get? Power, or you can say power is nothing but a work done. If the unit is in kilojoules, it is work done W. If the unit is in kilowatt, it is power. So here how we are getting directly in terms of kilowatt? Here he is divided by 60 because kilojoules per minute it was there. Now it is there in terms of divided by 60 has done. So you will get in terms of kilowatt. So power required divided by tons of refrigeration. So tons of refrigeration, power required is 94.78, tons of refrigeration is 25. So this is 3.79 kilowatt power supplied, right? So to do this much work, to get this much refrigeration effect per ton, you will supply 3.79 kilowatt, right? COP, total refrigeration effect divided by power supplied. So since this power supplied is in kilowatt, this also should be in kilowatt, but 5250 is kilojoules per minute divided by 60 will get into kilowatt. 0.923 is COP. One more he has asked in the question is V1 and V4. How to get V1 and V4? In the compressor P1 V1 is equal to MR T1. So V1 is equal to MAR T1 divided by P1. All the values are known to you. Expander, here also MAR T4 by P1, because P1 is equal to P4 I can write, P2 I can write here, but it is also equal to P1. So this is just check here. I think so it is P4 and P4 V4 is equal to both are same. P1 and P4 are same. So this will come around 20.13. So pressure is same, only thing is temperature is going to change. R is same, MEA is same, only value is going to vary based on the temperature. So this is how we can solve the problem. Next one problem we will take up. In an air refrigeration plant, here we are seeing earlier we have seen till now this actual ideal this refrigeration cycle. Now we will see the actual. Actual means what will be given in the problems we have seen. Efficiency of the devices will be given. An air refrigeration plant is to be designed according to the following specifications. Pressure of air at constant compressor inlet is 101 kilopascals. 101 kilopascals means what? P1, inlet of the compressor. Pressure at the compressor outlet, that is P2 is given and 404 kilopascals, and pressure loss in the intercooler 12 kilopascals. So 12 kilopascals means what? P3 is equal to P2 minus loss, right? So this is pressure loss in the cold chamber is 3 kilopascals. So from here P4 is equal to P1 plus loss is 3. So P4 is equal to 104 kilopascals. 101 plus 3 is 104 here. Sorry, he has written wrong again. So tons of refrigeration is equal to 210 kilojoules per minute, and here temperature of air at the temperatures now he has given at the inlet of the turbine 27, compressor and turbine efficiency is 85, and we need to calculate COP, and this one power required for 1 TOR, air circulation per TOR. Right, so these are all the given data. Just check again. So this I will write as 104. Right, we'll see in the next slide what will be. Right, next we'll just see values of T2 dash, and we'll take out the values of T4 and other things, right? T4 dash, right? So first, how to take this one? T1 is given, we don't know T2, calculate using this normal formula. But efficiency of the compressor, we know that in the previous problems also, in the gas turbine also we have calculated T2 by T1 divided by T2 dash minus T1. So in the compressor it is coming dash downside, and in the turbine it will be coming at the top side. So 85% efficiency is given. Substitute everything, all the values are known to us, only T2 dash we need to calculate, and hence for the further calculations we will take for T2 dash, and similarly we will calculate for T4 here. T3 is given, P3 is equal to P2, and P4 is equal to P1, not P3 is equal to P2. Considering loss, P3 is 392. Here also considering loss, P4 is 104. So don't make mistake. Again, I was just taking the previous values. Don't make these mistakes. So from this, you should note down the T4. So again, I know the turbine efficiency T4 minus T4 dash divided by T3 minus T4. So this is isentropic efficiency. This is isentropic temperature difference and actual temperature difference. Here actual temperature difference and isentropic actual temperature difference and isentropic temperature difference. So using this you find out T4 dash. So in this whole slide what we have done, we have tried to find out T4 dash and T2 dash. And but P3, P2 you just take care, P3 is not equal to P2 here, and P4 is not equal to P1 here. So already those losses are given. In this losses must be added in this losses must be this subtracted here added, right? So further part, refrigeration effect per kg, how to calculate Cp minus Cp into T1 minus T4 in the previous problem. Here we will just substitute as T1 minus T4 dash. So all the values are known to us. Substitute now. Mass of air, total refrigeration effect divided by refrigeration effect per kg. So refrigeration effect per kg is calculated here. Total refrigeration effect is effect he has not given. I think so he has not given. So we'll take 1 ton of refrigeration effect. So it comes around 3.15. So net work done is WC, that is work done by the compressor minus work done by the evaporator. Substitute. So but work done by the compressor, what we will take? Cp into T2 dash minus T1 and T4 minus T4 dash, T3 minus T4 dash. So substitute all the values, you will get the Wn. So power is equal to what? Ma into Wn. So P is equal to this. Ma is in terms of what? This one kilojoules per kg per minute, I think so. So kg per minute, we just so divided by 60, will get kilowatts. 79.46 is what W net. So 4.65 kilowatt you are going to get the answer. So solve more and more problems. If you have any doubt within these problems, you can contact through any media. Thank you very much. All the best for your final exams. Hence, I have completed all the modules. Thank you.